I was born and raised in Hoquiam, Washington, which is right on the Pacific coast, fishing and lumber village. Graduated from high school there in 1942. Then after World War II, I was in the Navy during World War II. In 1945, I was discharged in Florida and got back to Washington. And some of my former high school buddies were, at that time, were employed with the Boeing Airplane Company in Seattle. And being interested in aircraft since I was 9 years old, I applied for a job at Boeing in the wind tunnel and started that career as a model maker C in 1947. And with only a high school education, some of the work I was doing was a little bit complex, and the engineers helped me a little bit on some of that area. But as time went on, they encouraged me to go to school and transfer to the engineering department. So that eventually led to designing and fabricating and working with the models, many of which were tested here at Langley. And that was in the early 50s. And I think about 1968 or so was when the SST was canceled. That was my last trip out here. But during that period, I got to know many of the engineers and scientists here at Langley. And there were times when I had 7 model test programs going on at the same time in various wind tunnels around the center. 68 was the last work that I did on a wind tunnel trip. We did a number of programs. Boeing did a number of proposals trying to get government contracts and so forth. The cancellation of the SST was a big problem at that time. The supersonic transport, we were in our second version of that, which was more like the Concorde, except that it had a conventional horizontal tail and vertical tail, a delta wing, and was to be a Mach 2.2 aircraft, and so it was designated as a 2707 airplane. I did a very complex test here at the Transonic Dynamics Tunnel with that airplane, in which at that time we called it a flutter model, but it was a composite design, and in order to get parametric changes in the airplane, we used water to simulate the fuel. And so we had to transfer fuel, water, around in the airplane while it was flying to explore all of the conditions that the airplane would experience. As a result, as I said before, I got to know many of the people out here. And I think it was in 1971, a couple of years later, that they were having difficulty with the current models contractor to do dynamic type models, flexible models. And they put out a request for quotes for a new contractor. And one of the stipulations was that this new contractor had to be located within 30 miles of the center. The contractor that they did have resided in Boston, so that was quite a difficult communication problem for them. And the proposal was put together by myself and about 7 other Boeing employees. We were all interested in possibility of coming here, doing that kind of work. And after the competition, we did win the contract, and I was listed as a key employee. And if I didn't move, they would cancel the contract. So as you can imagine, it's quite a traumatic experience for 7 families to uproot from Seattle and move out to Hampton, Newport News, Williamsburg, and the surrounding area. We used a vehicle that had been originally initiated by a former weights engineer at Boeing, and then the company was called Dynamic Engineering. But they were primarily interested in drones, and they weren't doing too well with that. It was at the beginning of interest in drones for military use. And by using that, we were able to at least start out with an entity that Langley could recognize as a viable corporation. But we didn't have any assets to speak of to do the work once we got here. So we joint ventured with Modern Machine and Tool Company. And they were to provide space for us to reside and do our machine work and some of the initial electronic work until we could get established. This was in the winter of 1971. We actually were awarded the contract in July of '72. Modern Machine and Tool at that time was in Hilton Village, and a couple of years later we moved to Oyster Point in the new. We were the first occupants located in Oyster Point for industrial organizations. We had a special expertise in dynamic models, having the opportunity to build so many different designs at Boeing. And there are 3 basic wind tunnel types. A rigid aircraft, which is now called precision aircraft, and they're primarily to get aerodynamic data. And in the pre-jet age, all aircraft were considered rigid, very little flexibility. And so the wind tunnel models could then be built likewise with removable control surfaces and things that we could adjust during the wind tunnel test to get the different forces on the aircraft. The other 2 types are now called aeroelastic and flutter. The aeroelastic model is a sort of a bridge between the rigid or precision model and the flutter model. The aeroelastic model has to deform and bend the same way that the aircraft would in the wind tunnel under flight conditions. And the conditions that the airplane fly in are essentially the same as a full-scale airplane would be. If it was designed to fly at 600 miles an hour, our models had to fly at 600 miles an hour. And as a result, the aerodynamics on the airplane change as it flexes and bends under load. And so we have to get more precise data than they did with the precision model. Precision models were fine for a single condition, but once the speed or altitude or both change, then those conditions change. The flutter model, it was designed to represent the frequencies of the aircraft under load, not concerned with the deflections particularly, but actual frequency of motion. And we have to make sure that the aircraft does not get into a flutter condition that could ultimately destroy itself. And our expertise was in the aeroelastic and the flutter type models, and that's basically what gives us the opportunity. And that is a very essential part of starting any new business. You have to have something that is different than everybody else is doing in order to get a foothold or a foot inside the door, you might say.
Right.
That contract is still, well, I'm not sure. The precision model contract was held by another company from Tullahoma, Tennessee, and we had the flutter model or dynamic models contract. And as president of that Dynamic Engineering Corporation, we went from approximately $250,000 a year of income to $14 million by the time that I left the company.
What year was that?
1987. At that time, I decided to start another company called Strom Incorporated, which was to be a small company basically interested in doing similar kind of work that dynamic engineering did, but to do it without the massive overheads and costs related to a more sophisticated tech company, you might say. And in that same time period, there were changes taking place in the wind tunnel industry in which computers were being involved and developed to do preliminary design work and evaluate these different aircraft and their performance and capabilities. And that began to allow fewer and fewer models to be built and the related cost to that. They did the original parametric design studies using the computers, and then every once in a while they would take that design and do a wind tunnel model of it and do the correlation between the two, the real wind tunnel test values versus the computer values. And it ultimately, I could see this ultimately becoming virtually a complete system in itself, where the results of the computer would be capable of eliminating the wind tunnel models in the degree of work. Complexity and things always have to be checked out eventually. You can do a lot of work with a computer, but a lot of the work that's done on the computer is theoretical, you might say. And to validate it, you need to build and test and make sure that they agree. And then you can say, okay, this is correct. Now we can go on and try another level. Strom Incorporated gradually transitioned into a model aircraft design and sales company. We developed radio-controlled models and kits and various designs, aerobatic, speed, seaplanes, and so forth, and produced those kits for distributors in the U.S., and they were sold worldwide. And that went quite well until the technology in the model kit building business began to change, where instead of cutting equipment on inexpensive machinery like bandsaws and table saws, they were going into laser cutting. And I guess laser cutting was one of the biggest things, but another element was the advertising that was required, and the fancy labels and etc. It became very difficult to invest in that much and keep going. So we transitioned Strom Incorporated from a manufacturing organization into a model shop where we actually sold other people's kits and materials and so forth. It was located on the corner of Jefferson Avenue and Main Street. And
What year was that?
That was about 1996 or so. 1996. And it was in 1997 that a former associate of mine here at Langley asked me to come back out to Langley and act as a consultant on a flutter model program they were building on what they now called a super cruiser. And I had an individual then consultant's contract, which started in '97. And that gradually grew into and transitioned into the current single contractor contracts, such as ATK and Swales and AMA now currently. And I've been directly associated with Langley ever since 1997.
So that's over 20 years, right?
Mm-hmm.
And what contract do you work with now?
Teams 2. I'm currently a Northrop Grumman employee, and that's in transition now to one of 5 or 6 new contractors, subcontractors to AMA. We're not quite sure who that's going to be. We're going through the process of interviews and etc. One of the reasons I have my resume now is that I had to update it for that transition.
Oh my goodness. Do you have any advice that you could give the young people? I mean, you've been through over 50 years of work life, probably more than that, 70 years of work life?
Mm-hmm.
So you've started several different companies. They've all been successful and transitioned when the times necessitated it. Do you have any advice for people now in this day and age where computers and artificial intelligence and all the different things that are happening are happening all at the same time? Do you have any advice for people just now starting out from college?
There are a lot of things to be aware of, and one of the things is to never turn down a task that's been given to you, no matter how disagreeable it is, because you never know where that experience is going to take you. in high school took a semester of typing, which I thought was a total loss, never realizing that some 45, 50 years later I'd be using that capability on a computer. The other thing is don't be afraid to make a mistake. There are various organizations who tout no errors, no mistakes, and etc. But that's how you learn. You try, you have an idea, try it out. If it doesn't work, it doesn't work. But the knowledge you gain, you can't get anywhere else. And you build on that knowledge. Thomas Edison found that out with the electric light bulb.
How many tries did he have? Thousands?
Yes, he tried everything, but he kept going, and that's what built his whole industry. So that's one of my best recommendations is don't fear a mistake. That's the base, that's the foundation for what you're doing. If you're going into business for yourself, or you think you'd like to go into business for yourself, there are a few things you need to remember, and that is that you are very, very likely to never be really working for yourself. The financial requirements of an organization or even a very small company are such that you're having to acquire a money situation where your line of credit is needed, because the distance between when you start a job and you get paid for it can be weeks, months, whatever, until you have delivered the product and you get paid for it. My experience was that I had to search for a bank company that understood that requirement, and when they loaned me the money to cover the employees and whatnot through a contract, that we had to have that distance between when they gave you the money to operate and when you could repay it again. Prior to that, you find a lot of banks that require you, they'll give you the line of credit and the money that you need to function, but they require you to pay down that credit to zero at least once every year. And some contracts just don't fit into that scheme. So you're never really working for yourself. It's a good concept, and you do have more ability to do things. You're freer in your operations. To that extent, that's what makes it desirable. But you need to make sure that those things are covered. There are, as I experienced, some really gut-wrenching situations when you have a lot of employees and things don't quite come together the way they should. At one point with dynamic engineering, I had 250 employees, and out in front of us we had a drop-off cliff approximately 3 months away. And we went through, at least I did, I went through 15 years of that, with that 3 months out in front of you that you have to keep covering. And it's not just yourself. You've got 250 people out there that are requiring that you do a good job. Keep it going.
Can I ask you about, when you told me about moving 7 families from Boeing?
Mm-hmm.
What was that like for the families? And not only were you carrying the responsibility of the 250 employees, but I assume they all had families, so you're really talking about maybe up to 1,000 people, depending on the company.
Yes. Some of the people just couldn't make the change very long. Out of the 7 families that came out within, I'd say, 4 to 6 months, 3 of them returned to Seattle. But by that time we had established ourselves and were able to contact other individuals. We hired people from California, Tennessee, Ohio, various places that had, wind tunnel, people with wind tunnel experience or model design experience, and built the company in that manner. But the big problem with moving from one place to another is you're uprooting your children from schools, uprooting them from all their friends and the familiarity of the area and so on, and you have to really be dedicated to take that and reestablish, acquire new friends, get children to get out and make friends with neighbors and etc. It's a tough job, and many times people don't get credit for that kind of vision, that they could see that what we were trying to do was worth the effort.
What do you advise people as they go through their careers, how they can maybe change the direction of their careers like you did? What is some advice that you would give them?
Well, it's basically the desire to constantly be learning and wanting to stay abreast of where the world is going. I have, one of the major things that influenced my continuing to work was the fact that in talking with former Boeing financial people, and their comment, one of them made a comment to me that the average retirement check that was mailed out by the company, the number of those checks was 3. And the retirement checks are provided for as long as you live. Mm-hmm. And to me, that was quite a shock, that once the person retired and no longer had an active thing to do and more or less became convinced that he was of no use to anybody anymore, that influenced his lifespan and all of his activities. And the idea that the average person only lived 3 months past retiring was just too much of a blow. And I vowed that I was never going to retire. I'll go home when they tell me I can't do the job anymore, but I heartily recommend anybody, don't retire. Keep active, keep working, keep your mind busy, always be looking for something new. Don't turn down anything that's hard.
That's excellent advice. And can you just, before we close, can you tell us now what your current project is? You were telling me about it on the way here, the Learn to Fly project and the model that you built.
Yes, the aircraft was a 40% scale extra, designed by a gentleman with his last name is Extra. His model was 330. It's an aerobatic airplane, mid-wing aerobatic airplane. And our model had a 122-inch wingspan. And we purchased it as a kit, which I put together, and it was designed to be flown with a gasoline engine. And I converted it to all electric, as well as redesign and modify the internal area of the fuselage so that we could get batteries and avionics systems in it. The airplane was put together for the Learn to Fly, or LTF, organization, and they're currently going to be dropping two gliders from a balloon, and the computer is going to monitor the flight, and a pilot will be attempting to control it from the ground, and the computer is to learn what the airplane's environment is, its speed, altitude, rate of descent, and attitude, and so on, and teach itself how to restore it to level flight, conventional flight. And then they want to take that information and put it in our extra 330 and let a ground pilot take it off and get it up to altitude, and then switch over to the avionics and see if the data and the program that they're putting together will actually fly the aircraft. The concept is that once it has learned what it takes to fly it, then it will fly it itself. But you have to, in the gliders, the pilot is restoring the airplane's stability and converting from the dead drop from the balloon into forward flight, and the computer is recognizing all of that and how the pilot corrected it, how much he had to do with this or that, and then they're taking that information and putting it in the extra and take it up in the air and see if the computer now can fly the airplane.
That's pretty interesting stuff. And
yeah.
I got to say, you work with a lab that has a lot of young people in it, people that are just out of school or still in school. What do you think about that generation that's coming up now?
I think they're doing a wonderful job. They're having the advantage of learning this new electronic activity from ground up. They were doing things in school that we only dreamed of when I was in school. And when they arrive out of college and into our area as an intern, they have already acquired tremendous experience. All they need to know now is how to apply it. And I feel that that's where I come in now. I'm still able to show people how to apply it.
Do they have a good work ethic?
Oh, absolutely.
That's
absolutely.
Great.
And that's very encouraging.